Okay, everybody. Hi again. Welcome to YSoft. Welcome to Technology YSoft Meetup. Thank you really very much that you came today. I never really saw so much people in this room before, so really thank you. You're cool. So welcome again to YSoft Technology Hour. It's a community meetup for developers by developers, and I hope we will see you again another time. Today we will have here guys from Apiary. Before I introduce them and I will pass them the word, I would like to say please don't leave after the talk itself. There will be another, like the continuation of the event in another room where there is a lot of pizza, drinks, and also the promised 3D printer called D-Green by B3D, which is a company that we recently bought. Let me check if it's all. Yeah. If you enjoyed the meetup, then please follow us on Twitter, on GitHub at YSoftDevs. If you want to tweet about the meetup, please use the hashtag YSoftTH. You could also use our Wi-Fi, which I heard is down. So, yeah. And that will be everything from my side. And let me welcome here Zdenek and Kyle from Apiary.
Okay, thank you, Kuba. And again, welcome everybody. I'm happy to be here. My name is Zdenek, or I just go by Z. And here's my friend Kyle, who works with me at Apiary. And we'd like to talk about front to back or back to front API design. The name of this talk is not really about implying that it should be front to back or back to front. It's more about that both front and back matters when you design your API. So hopefully you will like it, and let's get into it. When I talk about API design, I have to talk about the API lifecycle as well. So I'll try to give you an idea of what I think when I say API design and what is API design and API's lifecycle afterwards, because when you design your API, it's not where it ends, it's usually a start at some point. Now, what is an API? And I believe you are like developers or people that are working in a technological company, so they have ever heard before word API. Is there somebody who doesn't know that? What API is? Raise your hand. No. Okay. So to me, API is an interface, and an interface between components in a distributed system. And this is like very important. The interface is between two components or maybe multiple components, and this is going back to my idea of thinking about API as an interface between two parts of the system. There may be multiple, but really we'll be reducing this to the two components of the system. Now, there are many kinds of APIs. The one I have in mind here is or are web APIs. This is something that comes from the age of the web, which we were living in and we still are. And with that, I would like to ask you: is there anybody who developed or consumed web API? Raise his hands or her hands. All right, that's pretty cool. Now, to give me an idea, is this more like a backend developers on the side of the distributed system or a front end? Who's a front end developer guy? Let's say. All right, so I assume it's like half and half. Very good. So let's look at the API design of a web API. Now, when one talk about the web APIs, we really have to go back to the history and start with the web itself and to understand where these ideas are coming from and what was the motivation for this kind of APIs. Now, I'm pretty sure you know the guy on your left, who is Tim Berners-Lee. He is considered basically to be a founder of the web. When in 1989 he was like really desperately sitting down in the basement of the CERN, and he was in despair because there was a lot of computers in that big house or corporation or this institution CERN is, and all of them has like definitely interesting research paper, but many of them were like on different operating systems. You had to learn how to program or access those documents, those research paper. And he was sitting there and realizing that he spends most of his day trying to figure out the access to these research papers to actually do some research he wanted to. Now he was wondering whether this can be improved, how he can improve the situation. As a side project of what he was supposed to do, he was thinking about how he can basically make his research easier, how to make an access to this research paper easier. And that's where he came with the idea of text documents interlinked through the links. And these hypertext documents will be sitting on some servers, and you will be accessing them. And as you will be reading those hypertext documents, there will be some things called links. Nobody knew them before then. And you could be like following those links from one document to another, and be reading those documents and navigating between those research papers. So he did, and I think this is like very common thing for us today: link and click, and interlinking two documents together. This is like why am I explaining this to? Like this is like every day. Everybody is like, from small kids now, use for links and interlink documents. So 10 years later, the other guy, Roy T. Fielding, came and he said like, wait, apparently in 2000, web is a big thing. Why is it a big thing? Obviously, there is this big social power when you have these documents online and they are interlinked, and they are sort of like hard to kill. You cannot really stop the web nowadays. I mean, you can attempt that as they do in China, but there are still like ways how to get around. You can try to block it, but it's pretty organic and wild-grown thing, and it scales like really through the immersive sizes. It's like a huge thing, and it's so natural part of what being a human is today. Now, Roy Fielding was wondering whether this can be sort of extended out of just interlinking the documents to learn from what web is and how web works, and put it into perspective of computers talking to each other, not just about the text document, but about any resources there are. So he looked at the architecture of the web. He sat down and he wrote this little paper where he basically described, an abstract paper, a research paper, where he described how the web works, what is the architecture of the web, and he proposed some improvements to this architecture so it might be used by computers for all different kind of medias or resources, not just these hypertext documents. So this was in 2000, and soon it really boomed. In 2000, arguably the first REST API was Salesforce API, and it followed by the other companies. Now the big boom really started in the year 2006, where Twitter and Facebook came up with their APIs, and people realized what they can do with them. They can like interconnect their applications and do different mashups. And essentially, if you think about it, it's just like a remix culture. This, having a public API, the access to your company's data or to your company's resources enables an applications or building other distributed systems that you couldn't even imagine before. And this is again back to why web was so popular. Now, REST, as Roy Fielding described it, is an architectural style. It's not a protocol as it's shown on this infographic, and that's also one of its problems. REST is a guidance or a design pattern you should be thinking of and you should honor if you want to develop a web-like API. It is not a set of tools or libraries or protocols that you will just use and you will get REST. That's a misconception, and if somebody thinks about REST as a protocol, then he will soon find out that he might not be or she might not be really conforming to the REST. Now let's look at what this architecture actually is. So REST architecture is a set of design principles. It is a set of constraints you put on your system when you are designing that system. And there are several constraints. And if we'll go through them, the first one is the client-server environment. That's fairly straightforward what it means. There is a client and there is a server, and they talk to each other. Basically, server serves the client. Second constraint is that the system must be stateless. What it means? It means that the server doesn't retain the client states on its side. That means basically that the client sends all the information needed when he makes or she makes the request. So this enables, if you think about it, what it means, this enables scaling. Basically, if the server would be storing the state for every client, and this would not basically scale. That's how web pages are working. Again, when you are thinking, hey, what is this guy talking about? Just think about, try to picture it on the web. The regular web server doesn't really retain any state of the client on the server side. Now, third constraint on this architecture, on this distributed system, is that it must be cacheable. This is for a whole new talk. You might be interested in talking about caching, and as everybody knows, there are only two problems in programming world, and one is caching, and other is naming things, right? So, there must be, in this REST principles, there must be, it must be possible to be able to cache the messages. And again, if you think about it, this solves the scalability and performance problems. Now, client might be able to do requests that never reach the server, but they will still get the answer back, and it still might work. So again, try to think about how web works. Now, fourth constraint is layered system. That basically means that client, it should be opaque to the client, to who he talks to. Not who's like the origin of the server, but the client shouldn't really know whether there are some layers between the client and the destination, the server. There might be some proxies, there might be some load balancing in the place. Again, this helps with the scaling and helps this distributed system to be like really well performant under big loads. Fifth is a code on demand. Now, code on demand means that I don't download the code and do something with it, right? And this is the only optional constraint in this REST architecture. Now, does anybody know what would be a code on demand when we talk about the web pages? Any ideas? What is a code on demand when you have a web page? That would be a JavaScript or a Java applet, where server provides you a code that is executed on the client. It might be used for validation of requests or whatever, but basically server gives you the code, clients execute it. So again, this is one of the constraints of REST systems. And the last, it's a uniform interface. An uniform interface basically, again, helps all these constraints when you think about them, really helps with the scaling these systems, and that's what you might be interested when you are designing your APIs. If the scaling is not a problem, you probably don't even want to think about the rest. You just hack it somehow and it will work, and if you want to scale it later, then well. So what a uniform interface means, it comes with four sort of sub-constraints. One is that every resource in this API of this API should have a uniform identifier. That means basically the URI. You have an URI of a web page or of something. So that means that there is one particular identifier for that resource. Now, second one is a manipulation with the resource. You are manipulating. You are not really dealing with the resource by touching that resource directly. You are dealing with it through some representation. That's a very important thing. Think about it. You have let's say an active record or in Ruby, and you have a JavaScript application. Well, how that thing can how JavaScript thing does something with Ruby? No, well, it does not. It has some representation of that thing, and it talks with the server through this representation, not really dealing with that particular implementation that's on that system. So that's what it means. self-descriptive messages. That basically means that the messages that are going from and to the client are self-descriptive. There is no need for out-of-the-band information to process those messages. So you have all the information needed to proceed and do something with the message. And last one, and I have it here in bold, is hypermedia as the engine of the application state. Wow, this is a big one. So I'll get to it later, but this is the one that we are really missing in nowadays web APIs, and this is like what really sort of breaks what brings the bread and butter of what web is, and this is basically the interlinking. I will explain it later. I just want to say that there is nothing about HTTP here. In the REST, there is nothing about HTTP. REST might work without HTTP. It might use a different protocol. That doesn't really. That's not one of these constraints. Now, obviously, HTTP is one of the protocol used to build REST-ish APIs. And why? Well, it gives you most of these constraints for free, so you don't have to worry about them. Now, what it doesn't give you is the self-descriptive messages and the hypermedia as the engine of the application state. Well, and we are lazy programmers, right? So if that doesn't happen with the HTTP, then we probably don't even know that there is something like this self-descriptiveness of messages and this HATOS, hypermedia as the engine of the application state. Well, so let's look what REST is not, just to make sure. REST is not about pretty URLs. There is nothing about how URL should look like and how you should name things and those like big identifiers. It is not about HTTP verbs. It is not the CRUD, and it's definitely not the JSON. Now let's look what this last constraint or the sub-constraint of the uniform constraint, uniform identifier constraint means. If you are on a web page, if you are looking on the web page, how do you know what you can do next with it? Any ideas? You are sitting in your client browser, you are looking at your browser, you are looking at the web page. What you can do with it except shutting down the browser and go out or have a beer? I mean, with that page, you are looking at that page.
There is the DOM.
What is it?
Document object model.
Right, but as a human, you are looking.
Click a link, press a button.
Oh yes, that's the thing.
Facebook like button.
Exactly. You click on
advertisements
on one of the links that is on the page. You don't click on a link that's not on the page. You usually do not go to a link that is not on the page. You look at the page and follow what is available on that page, right? This is like super normal. Unless you have a bookmarks. Well, bookmarks are good, you can remember links somewhere and half a year later realize that the bookmark is gone, right? So, when you are on the page, you click on a link that is on the page and that takes you somewhere. But you check the important thing, and this is like, I know you are looking at me like this is like, hey, oh, well, that's a big, right? Well, this is like super important. This is like the core of all this, what I'm talking about here. You click on one of the links that are available on that page. The server tells you what links are there. Not that client read somewhere in a book, in a documentation, hey, I know, I read that, here will be those links, and then you click, go there and you see it, and then you still try to execute it, and you end up at 404, right? No, the server tells you what is on that page, what links are available, and you select one from those links that are on the page. Not that you read it somewhere up front, and then you expect it to be there. And this is HATOS. This is the hypermedia as the engine of the application state. This is basically you deciding from what is available, which path you will take, not you reading somewhere, what path should be there, and then you are lost. Now, to wrap this part up, it's basically saying that REST is that server should provide you with the links, and the client should rely on them and pick one of those available links and do something with it, basically transition the state. Well, you don't have to do this. This is a software architecture, this is a design. You might decide, well, I don't give a crap about that. You know, I don't need links. I will just read the documentation. I will execute some URL and hope that, you know, something will be as it was set in that nice PDF or, you know, Word document. Well, you know, if this happens and API changes, you have a problem. You have to redeploy the client, right? Now imagine what it would mean for the success of the web when you would have a web browser, and you know, the server that serves the pages would change, and you would have to install a new browser just because, you know, you want to you know, consume that web again. Well, that wouldn't work, right? Then we would not be ending with our, you know, lives living in this web browsers thing. You would, every time you know, a server would change or the API would change, you would have to install a new browser. Or think about it from the mobile developer's perspective. You are an iOS developer, you are developing an app for an iPhone or iPad, whatever, and you are consuming a third-party API. Now you develop that, you are not following the link, you are like memorizing in the app what links were there, and you are hard-coding those links in the app. You know, create your nice app, you send it to the Apple. It takes 2-3 weeks for Apple to review the app before it proceeds to the App Store. And you know, once it's there, you know, it's approved. You know, your users can download the app and consume an API through this nice application you made with this hard-coded link in it. Now the server changes, the links are gone, your app is broken, right? And even if you realize it at the very moment and sit down and, you know, change that in the code and send it to the Apple, it will still take 2 weeks or 3 weeks or whatever for Apple to review the app and send it to the App Store. So, you know, your users will be left in the dark for, you know, 2-3 weeks. And that is sad, right? So now when we have some idea what a good design for a scalable application might be, how do I do this? At the Apiary, we came up with a language basically that we call API Blueprint, and it's a plain text language to describe an API or define an API, if you will. It's a Markdown. It's a plain text where there are some semantics assumptions on how you write this Markdown, but basically you just write this text document. I have an example here, and this is basically the design of an API, right? Well, this is probably not, you know, the best API in the world, but it says, hey, my API is called my API. Sorry, I was not really thinking that much. And there is a resource, it's called message, and I can retrieve and go and retrieve that resource. It will return me some JSON thing, it says hello world. Now, this is it. This is what we think you should design, you know, your API, and you have just this plain text, and this plain text can live on a GitHub, or, you know, you can send it to a colleague, and discuss this, and everybody can read it. This is not really a technical thing. There is a lot of, you know, there might be a lot of text. It's a plain text syntax. Now, this document might be good to, you know, if you understand this, what is written there, say, hey, well, can it be, you know, I don't know, can the message should be something else, or should there be like create a message, or I don't know. So you can already sit on this document with somebody, preferably from the other side, like you know, server and frontend guy, and discuss this interface, just using this document. Now, this is not obviously just that, what you can do with it. But at the Apiary, we think of this API design in a prism of a life cycle, where we think that you might start with the design. Well, if you are starting with a new API, you know, when you have an existing API, you might jump at some point later. Now, if you are starting with your API, you start with the design of your API. You'll describe this API in a very sort of human readable way, and immediately once you do that, we'll provide you with a mock server which goes to the prototyping phase, where you can already, you know, by just writing this Markdown, you can already make calls to an existing endpoints. That will be like stupid mocking service, but still, you just wrote that little Markdown, and you have those endpoints. You can really play with the client and test it right there if that's doing what you want. Now you can have some iterations between design and prototype and play with it and, you know, improve your design. And when you are fine with it, and most importantly, when all the parts involved, all the stakeholders involved in this API are fine with it, you can probably move forward towards the implementation. Once your API is implemented, it's important to say that with the implementation, that hopefully everybody here is aware of test-driven development or continuous integration, right? Okay. So when you are implementing it, you can take this design of your API. This is like sort of a contract between whoever is developing the API, whoever designed the API, maybe whoever is consuming this API. So you take this contract as you are developing your server or your backend implementation, and you can test this contract, or more specifically your backend implementation, whether it conforms to this contract. So that's the implementation part. Now it's probably time to deliver it, but you were definitely discussing your API while you were designing and prototyping it with your clients. Now when you deliver this API, you probably want to have some nice interactive documentation with so the clients can like really start and basically develop against your API. And as they are developing it, there might be some tools that are helping them to do that. For example, traffic inspector, like seeing what calls are there, whether they are sending what they wanted, or whether they are getting what they wanted. Now this is also where design helps. Well, once you are there, we can close the loop with getting some feedback. Oh, this doesn't work as I wanted, and this should be something else. And once you have this feedback, you can close the loop and revisit your design, change some things, and keep going in this. So this is basically what I mean when I say an API lifecycle or API design lifecycle. Now Kyle here will demonstrate some points, some parts of this lifecycle. How do we see them, and yeah. So this is a question?
Yes, before Kyle starts, my question is, you said this is the rest. The second point was
the constraint.
Yeah, the second constraint was
stateless, if I'm correct.
There is no state.
Mm-hmm.
How do you deal with sessions?
Well, that's still alright. You can have a session. By the point of a stateless here, you can have even some client data stored in some persistent layer, like a database. What stateless means here is basically that the server does not retain the states by itself. The client provides all the information with every single request to the state. So let's say he or she, the client is identifying it itself by an identifier or token or whatever that basically says, hey, I'm this client or this guy, and the server might retrieve some information from the persistent store. Now the idea here is all the necessary data to do that are sent in that request. Does it make sense?
Nope. So actually, you mean by the statelessness?
So
that there is no state related to the objects inside the API, because the session is actually outside the API. Am I right?
The session is the client identifies itself, yeah, for somehow doesn't matter what it is, and
well, actually,
let's say all right. So let's say the client needs to do 2 calls for some reason. Send something there and then later on do something with it or something like that. So the server doesn't like really wait for that client to make the other call. It basically there might be like many clients coming in between and doing either part of this call. And when the time comes for the client again to make the second call, the server gets all that information from that request. It doesn't retain any state of that client processing on its side.
Unlike the session itself.
Well,
because actually I can't store the session data, I can't store the authentication, I can't send the authorization tokens to the client over the network.
well, the client is sending it to the server, right?
Then there is a security hole.
Well, the client is
Inside.
the client is identifying itself to
The
the
client
server,
is identifying
right?
itself
So,
by some token, which in turn is a key to the persistent store,
Right,
which is somewhere in the server infrastructure.
right. That's correct. That the persistent store is there.
But
whatever
the
it is.
persistent store actually creates the context of a session.
Right, but that's
so
not.
it doesn't mean that the rest is contextful, because the context of the session is outside the REST API, if I understand it correctly.
The context of the session is outside. Say it again.
Of the REST API, because it's outside of the object
Of the
being
when you
modified.
say REST API
Yeah.
of the backend application.
Yes.
Correct. That's correct. Yes.
Thank you.
No problem.
Hey everyone, so I'm going to show you how to sort of design your own API using Apiary. So to get started, I'm going to create a new document on Apiary to describe our API. And it's going to be an API on creating polls. So it's an API where you can like create a poll, a question, and then people can like vote on it and stuff like that. So to get started, you can see here this is where you describe your blueprint, where you sort of define it. So to get started, here's how it looks. So we defined the name, a simple description of what it is, and we started describing a group of endpoints. In this case, an endpoint called polls, which allows you to get a hold of a bunch of questions. And this API is going to, or this endpoint is going to return us a JSON blob, which has an array of different items. In this case, we have one poll, one question, which is what's your favorite programming language, and there's a bunch of choices. So quite quickly, this has allowed us to like preview this documentation. In here. And it also allows you to get a mock server, so you can actually have this URL which you can request, and it will give you data back exactly from your blueprint. And we can grab an example like command here to run it. So I can run this in the terminal, and it's actually going to return that JSON blob back along with all the headers we defined. And it doesn't stop here, because you can actually grab example source codes. You can, if you're doing like a website, you can use JavaScript, gives you code to test it quite easily. Now what I'm going to do is use this URL for the mock server, and I'm going to pump it into an app I've already built. So I've already built a complete application which uses this from the mock server. So I'm going to paste in the URL we used for it, run it. Right, so we have this app here. It shows you a list of polls. You can't really interact with it. There's not much you can do with it. There's not many links you can follow that were defined in the API. So if we look, we can actually use the traffic inspector to see what was sent. So in Apiary, the mock server logs everything you do. So you can go into the traffic inspector, and we can see this request we made, and you can see it got the response. You can also see it actually asked for something else. It didn't ask for JSON, it asked for a format called Siren. Now Siren's a way to provide HATOS sort of style links, so you can define your links in the API and your client can take it on from this document. So I'm going to change our API slightly so it will be able to provide those. So if we go back to our editor, I'm going to add this new response type. So I've added a second response, which is a 200, and it provides siren back. And it provides this siren document, which is based on JSON, but it sort of describes how certain things work. So it has links to the next page if there's pagination. And if we go back to our app and we refresh, it's now, well, that's not good.
There's a backslash error in the JSON.
Ah, it's missing a plus. So now our application is switched over to using the siren version. Instead of the ordinary JSON version. And this allows us to provide it with different links, as we mentioned earlier. So imagine if we added this new, as you can see that you can't like slide this to delete it. Now we want to add this, the client already knows about it. So let's add this into the API. So in here we can easily add this link. So it's described here in the API that there's this action called delete, and it's to this URI, and it's the HTTP delete. So now if we save this, go back to our application, refresh, so we've changed no code, and this delete button's magically appeared because the server told us we can delete this item, whereas before we couldn't. Wouldn't it be great if we could add more? So we can't add a new poll right now, but we could add this to the API. So we have this action called add to this URI with this method, and it expects a form encoded thing with these fields. So it expects questions and choices. So we go back to our app, refresh again, and you see this plus button's magically appeared. And it's because it's found this new action in the blueprint, or the mock server. So it's created this form based on the attributes there. So we can say a question is, what's your favorite color? We can add some answers. So we've got blue and red. Now, when we save this, it's gone off to the mock server again and followed the link here. And you can see what it's actually sent this form encoded item. Now, wouldn't it be great if we could change this? So imagine if we could change, like add a new field to that UI. So instead of just having the question and choice, what if we wanted to provide a new option in here? Let's say we wanted a subtitle. Now, we'd have to change our client, right? We'd have to redevelop it, change all the code, add this new item in the UI, and redeploy it to the App Store. But if we're using something like Siren, we can describe this inside here. So we go to our fields for this action, we could add something new. So we could add a new field called subtitle. Now once we save this, we can go back to our app, reload it again, and you can see this field's magically appeared based on what we've changed in our application, inside our server. So our app has no code changes to add this new field. Let's say we also want to provide a new type, so we don't want it to be sent as a form encoded thing now. We instead want it to be so I'm going to describe the action it's used so we can see it a bit better. So by default it was using form encoded before. Now we want to change this data type to something different, so like JSON. So we want to be able to send JSON instead. Now what we can do is we can simply change the link. So instead of sending form encoded, we tell the client what we want. So we tell it we want JSON. And now, if we go back, refresh, now we create a new one again. So favorite color, subtitle. We don't really have one. and red, blue. Now if we look at our mock server, we can see this actual request is changed to use JSON instead. Not sure if you can quite see that. So this really allows us to change things. We could also change the endpoint or the method, the HTTP method, so from post to put or patch or whatever, and the client doesn't need to know because it doesn't have this hard coded, it's just following links from one state to the other. And that's it.
Thank you, Kyle. To me, it's still amazing that this works. Now, basically, all we wanted to say here is that we are better together, and by that I mean the client developers and the backend developers. And when you design an API, you probably want to have the clients in that design and communicate them what your design is and how they should conform to it. Because even if your server provides all these nice links, when your clients just hardcode the stuff, it won't be any good. If all what the browser wouldn't be able to follow the links, but you would just have to manually copy and memorize URLs, then it won't be any good. So the point here is, as you've seen, client has to sort of conform also to these constraints and must not take on his or her shoulders the knowledge of a server's logic. You're really just driven by the links that server gives you, and thanks to that you can develop a clients that are loosely coupled, only loosely coupled, contrary to tightly coupled with the server. So you can evolve the server while you will be not breaking your clients. So that's the idea of.
Do you have any notion of versioning?
Well, that's a good point. Well, what do you want to version?
The different states of the API, because maybe it breaks the data behind when I change the interface.
So one thing that basically a good question to ask is when you have questions about this sort of design is how does this work on the web? How are web pages versioned? How does this work? Well, when you think about this, they are not really versioned. There are some media types behind that browser understands and can display, and those media types are of course versioned. And if you don't update the browser to support the latest greatest image format, then you probably won't be able to display that. Now the content as such you don't really or the offerings of the API you don't really want to version them. Now, once you start versioning this sort of affordances that API affords you to do with it, then you are on a slippery slope to maintaining different versions of that API, and that ends up to things like Facebook did recently when they announced that they are freezing their APIs for 2 years. They guarantee some sort of stability, so clients can be safe and sit at home and knowing that the API doesn't change in I don't know what they promised, 2 years time, and I don't know what happened after those 2 years. Facebook will come and change the API. Everybody has to sit down, read what they did, and change their clients. So if you start versioning this affordances, what API affords you to do, then you are in a situation where you probably don't want to be, because you will have a problem as you will try to evolve your API. So you don't want to version affordances of the API. You want to version, let's say, the media types that you are offering or the data that you are offering. You might be adding some new cool features to that thing, and you might later on learn the clients how to process those features, but you don't want to fundamentally version what APIs offer. Does this answer the question? Okay. Question?
How do you document those actions and the delete add or fields? Because there has to be some documentation of these. The client is supporting them, but we didn't see any documentation of those.
Well, so I think Kyle went really quickly through render documentation there. Now, if you have So sorry. The question was how do you document the actions and perhaps the data that the client is sending? Through this is the only thing you should be documenting.
Exactly.
And the API can show us the documentation here. So at the moment, we have in the blueprint, we sort of have these actions. Like here is list all the questions, right? And you basically say what it means there. Now this is can you close this right part? Yeah. So this is obviously incomplete documentation, but this is basically what the client developer should be reading. This and only that. The client should have some notion of your API domain. Let's say you are, toaster service. So you are providing like toaster service to different toaster as a service. That's pretty cool. Huh? And so the client who wants to develop a client to control your toaster as a service probably needs to understand this application domain. They need to understand what is a toaster, they need to understand what is the toast, what is probably cooking and all this crap. Now, that's basically the only thing that the client should understand. The client should understand the semantic of the domain, and this is what they should be looking at. Now, this is obviously really empty, and that deserves some better documentation. But it's basically say, hey, there are some questions. It should say what questions are. And there is a collection of questions, and you can list all the questions, and there should be an explanation to the client what is list in collection means and what creating question means. So it should be basically here explain what a question is. So a question is a question to somebody, but it consists of a question itself and maybe the author of the question, right? So that's what you need to communicate to the client. And you can create a question. That means that you will introduce a new question into that system. Now, what messages are being sent, what URLs are behind these things, that should be no concern to the client. Because once and how it is implemented should be no concern to the client. Because once clients start to thinking too much about how is this implemented on the server and how this works, then it's usually the point where the tight coupling between the server and client starts, and you will not be able to evolve your server without breaking the clients. So in a truly RESTful APIs, in a so-called hypermedia APIs, you really should care just about defining the semantics of your domain. Does this answer the question?
You didn't show how you document, add, and delete.
Maybe you could show a more variables documentation. You have there some more.
Well, let me think.
Add has some parameters. And
Some real-world example.
Real-world example.
List example.
Oh yeah. So this is my idea on how it should look like. You have basically the only endpoint to your API that you should know. This is sort of its description, what it means. Now, if you would look under the hood, you would see that it affords you with a possibility to list all the gist. This is sorry, I didn't say it. This is basically, if you are familiar with the GitHub gist or gists, this is a pastebin service where you have these little textual snippets, and yeah. So there is an entry point. This is really the only API you should have in your client, and from there you move on, and you'll get just a notion of what gist is. So basically, when you look at it, you sort of hardcode this API route to your client, and then you will write your client in a way that when it gets something it understands, it can display that. Now, if it gets gist, it's said here that gist has this data in it, and they are probably somehow explained to the client that what the client might do with those. Here is an example with the editing, and well, create maybe. So you want to really describe two things. One, to describe the attributes of the resources. Here is just, well, this is a good one.
Are the colors displaying the idempotency of the API?
Well, yes, this is not really fortunate, but yes.
So that means that it deletes the resource.
Good eye here, and yes, that's correct. So what I was saying is, you want to describe your resources attributes, what are the data in the resource, and give them a semantic meaning, and then you want to describe, you know, this affordances, what they mean, and we are working on the way how to display the parameters and attributes here for this affordance as well. Obviously, when you perform a transition, when you are following a link, it might take some attributes. In some case, like on a web, when you are sending a form, so those are sort of attributes or parameters of that request. So those should be documented here under this affordance as well, which is not the case here. Sorry about that. I don't have a better example now. But really, when you think about the resource, describe what the data are in the resource, what are the attributes of the resource, and then describe what are the affordances, these actions you might do with the resource, and what attributes those affordances are taking. Okay. Any other question?
Doesn't this mean actually that all the clients will be the same?
Precisely. That's the question is whether this means that all the clients are the same. Well, are all the web browsers the same? Now, answer is yes and no, right? So there is a notion of the generic client, which takes most of the heavy lifting and does most of the work. Now you still need to train that client to, to this particular domain and display, let's say, a question in some way, a button in some way, an icon of a toaster, or maybe an icon of a toast. But basically, this reduces clients down to a mere presentation layer, right? You just need to train the client to know how to present some things to the user. That's fundamentally what they are, and they are really just representing what the server is sending them. And so there would be a core that would be fairly general to amongst all these sort of clients, and there will be a thin presentation layer that will apply this application domain to display it in a certain way. So you are right.
It actually removes one of the, I think, greatest benefits of these APIs, that you separate the client and the backend, and then you can have like really any client you want. There is a freedom.
Well, that's actually
you are removing this freedom.
No, I'm actually not removing the freedom. I'm actually bringing more freedom. I know this is not a politics, but let's say there is back to my toaster analogy. Let's say there is a lot of different companies that provides toasting toasters as toasting toast as a service, and you write one client because you understand this application domain. You understand these words, what they mean, and how to represent them if you get them, or these actions and how to represent these actions if you get them. So you write this client once, and you can use it with any of these companies as long as they are speaking sort of this domain language, right? Mm-hmm. So this basically enables your this basically creates universal remote controllers in some sort, and or maybe a better example was a friend of mine. He was working on a startup that their aim was basically to provide a hotel experience through your iPhone or to your a smartphone, where you would come to a hotel, you would check in or call a room service or order food or I don't know housekeeping, whatever, through your phone, right? Now there's apparently many hotels in the world, many hotel chains. All of them have different backend solutions. In a hotel from hotel varies in what they offer. Some might they have housekeeping, some might have these features like air conditioning, and some other not. Now you have two options. You can develop a dedicated client for each one of these, or you basically mesh up these APIs, and at some point those APIs will, you know, speak the same language, this hotel domain, because there is only this many, you know, things that might be in a hotel, like, you know, domain, and you train your client to understand this this domain. And once you have that client, you might use it in various scenarios in various hotels and in various settings where those hotels might have or might not have, you know, some of these features, but the client will still work, you know. So it depends how you look at it. One might argue that if you don't, you might. Me saying to you that, you know, server offers you something and you should be following that sort of limits you in that, well, I want to use this and this and this that way. You know, not the way the server present that. Well, you may do that, but now if you do so, it's your free, you know, choice, and you must understand that you are trying to this tight coupling to the server, and once the server changes, you know, we will be left in a you know, world of pain. So it is. Again, it's an architectural style, and it's up to you to decide whether you want to use it, whether it makes sense for you to use it or not. And you don't have to use it. If you feel like, you know, not following what server offers and doing something smarter is the way to go, then you are definitely welcome to do that. This is basically saying how to design a system that scales well.
Is it used a lot?
Well, it's picking up. Basically, you saw that the question is whether this sort of API design is used a lot. My answer is it's growing up year and year and year. Every year I see like more people trying to you know, grappling with the same problems, because they are most often than not, when you have a major API, you start hitting these problems with scaling and with versioning. And when I go to an API conference, I always see people like grappling with the versioning and how many, you know, versions of the API they should keep, and how do they scale their API. So, and as we move through this situation, people are realizing that there might be a smarter way, which is this sort of design, to you know, design systems that should really scale. So it's picking up. I would say it's not really super popular at the moment. People are still, you know, grappling with these ideas here, and frankly, it still might be more work to, you know, follow this than just hard code URL, boom, you know, spin the client. Now we are trying to change this at Apiary. We are trying to bring some tools that will make this actually easier to consume this kind of APIs. So I see the situation changing, and yeah. Another question.
Last question, because we're almost an hour long. So last question. I think Zdenek will be here for the meal.
Absolutely.
For quite some time, so you can ask him questions directly there.
Question?
Yes. So actually we have this thing. We use links and everything in the API, but then we want to keep our. So we provide this backend system, right? And we want our customers to update that system, and then the clients don't want the behavior to change, but we do want some APIs to behave differently, right? So the action is a bit different. So how to do that, right? Because that's maybe why as people ask about versioning, because even though you follow these like operations which are available style, then you end up with, I don't know, action revise 2, revise 3, which are doing a little bit different things, right? Because also you're providing a client application, and in your latest client you want to use the latest behavior, but your customers still want to use the old behavior. So,
well, so the question is how to say it, how to like evolve.
How to evolve and still keep the behavior of customers who are used to some behavior the same.
So there are basically 3 rules of you know, evolution, or not evolution. How do I say it? of a backward compatibility. Basically, they go like this: you are never going to take away something you have already put there. Two, you are not making something that was optional required. And third, I can't remember. Well, you might help me with that.
So you can keep adding parameters of the same action.
Absolutely, you can keep adding some.
Right,
some
I just mean that in the end, you talk about scalability, right?
Mm-hmm.
But in the end, you might end up that you have a lot of operations, which some of them are deprecated, basically, or
that is
your parameters might grow, right?
This is again. So, and this, I don't want to be albistic here, but this is not saying that sometimes it's like so much burden, and wrong stuff. You need to really wipe the slate clean. Now, hopefully, this doesn't mean that you will need to, as you are adding functionality, you will need to do some semantic versioning of an API. This would be wrong too, and a lot of burden on your backend. So. You basically want to first explain to clients how they want to consume that, and you don't want to break them. So you are not going to take away something you already introduced. That's the main thing, and making this optional things required. That's really hard to say. There are some, it depends from like case to case. There are some things that might be like resolved by redirecting or but redirection to a client. Now web browsers already can sort of handle it quite well. Now most of the API for most of the API clients, like let's say mobile clients, when they get redirect back, nobody's really knowing what to do with it. So yeah, well, think about it as again, last with my toaster analogy. I'm really quick. So think about a toaster you have, and you have a state where you, in every state of the toaster resource where you put the toast in, you can set a cook time, right? So you want to you are affording the client to set a cook time at any time of that toaster's life cycle, toaster life cycle. So, and now for some reason, let's say later on you have set your clients, hey, there is a cook time, and you can set it at any time. Well, you don't say it that you can set it at any time. You say there is a cook time, and clients should look at the resource and say, hey, I can set cook time, and it should display, I don't know, a dial or a slide or something like that. Now, eventually, at some point, you realize that you don't want a cook time to be set when you are already, cooking the toast, when you are toasting. So you have introduced that, and later on, you realize that you don't want to set cook time when the resource is cooking the toast, right? So you take that affordance back. You take that link back that you have already introduced. Now, the client that was exercised, so to say, in a way that the client looks whether there is a cook time. If so, I'll display the slider. It will still work, right? Because you take this cook time away, and it just doesn't display the dial, or it just doesn't display the slider. Now this won't break the client. It would still work. You don't even have to restart it. This is fine. Now, if you take out something like toasting the toast, then you are ultimately screwing the thing, and there is really no good way about it. Once we start taking this sort of affordances or this sort of resources out, then you are really breaking your client. So
yeah, I think the thing is we don't actually want to remove resources, etc., right? But it's just if you want to change the behavior, right, then you are running into a trouble.
Well, behavior in what sense?
But I mean, the behavior of the backend, right? So
well, that should be totally opaque to the client. Clients should have no notion of how the backend works.
Right. That's for sure, right? It will not break the client, but it will change the behavior to the end user. So if you want to do the change in the backend, then you have to instead of using the action which is there, introduce a new action, and then introduce clients which would use that new action, right? Or I don't know about anything else introducing new API.
This is like turning to like really good discussion. And
excuse me, may I have one question to my colleague? Are you thinking about changing the implementation of the method?
Yes.
So actually,
The contract
what
changes.
the toaster does from baking a toast to freezing it,
Yes.
it's a new method, isn't it?
That's a good point. So you should not. You should not be messing with the semantics. So you can take some things away and still it might work. You can do some really crazy stuff. Now, if I'll have this chair here, and I say, hey, I call this chair, right? And then I afford you with this affords you to sit on that, right? Cool. Now, if a few months later I come and say, hey, this is a chair, right? Well, I can still sit on that, but probably you are doing something like horribly wrong, to your API domain. You don't wanna mess with you don't really want to change the semantics, the meaning of things. If you do that, then you are like ultimately like breaking the contracts and sorry, there is no way. So you cannot say like cooking means freezing. Now, if you do that, well, there's not much you can do with that. So you can introduce a new functionality to the toaster that it will actually cool off the toast. You can add it there as an affordance that will, when you press that, when you follow that link, when you click that button, freezing, then it will actually cool down the toast. But you should not be really changing the meaning of cooking to actually freezing.
Yes.
Okay.
Thank you.
Please use for I hope we'll all meet at the Relax Room, and just before we finish, I made a promise that I will always announce a new technology hour at the end of the current one. So today I'm glad to announce that the next technology hour will be with Mark Zeman, and he will be talking about FSCheck, which is like a framework for property-based testing in F# on .NET. So I hope you will all come here and see for at least those Scala developers here that I saw much. So, okay, now let's eat. Thank you.